So as I have already mentioned, vector is something that has magnitude as well as a direction, right? So I have drawn two other vectors. As you can see, I have a vector x and I have a vector y. So from this vector, the vector x, you can see this is heading to this direction. By looking at this arrow, actually where this arrow is heading to, you can actually say the direction of this vector. And from the length of this vector, you can actually find, from the length of the arrow, you can find the length of the vector. So I have another vector over here which is y, and which is having to this direction. Now I'm going to add these two vectors. Before performing the addition, before adding these two vectors which are x and y, before adding them visually, you need to understand one thing. You need to understand that for the vectors, that if you get the length right for any vector, let's say vector x or vector y, if you get the length right and if you get the direction right, then it doesn't matter where you actually draw it. For example, this vector x, I can draw it over here. This is also the same vector as long as the length are the same and the direction are the same. Okay, the lengths and the directions are the same. As long as the directions and the lengths are same, they are the same vector. I can draw it over here as well, which is also vector x. As long as the length and the directions are correct, okay, I can draw it up here as well, which is also vector x. In the same way, you can draw vector y anywhere. You can draw vector y up here, okay, or you can draw it here, okay. As long as the magnitude and the direction of the vector are same, you can move them around, you can draw them anywhere. So and this is very necessary to understand before performing addition. Okay, so let's add vector x and vector y visually. So before adding the vectors, as I said, you can move them around. What I'm going to do is that I'm going to draw here vector x of the same length or of the same magnitude, and I'm going to put the tail of vector y in the head of vector x. Okay, so as you can see, I put the tail of the vector y in the head of the vector x. Okay, and as I said, as long as the magnitude or the length are same, you can draw them anywhere, it doesn't matter. So if I add vector x with vector y, what happens? I get a vector z. So, and it actually makes sense. If you add vector x with vector y, you get vector z. How? If you think a displacement occurred over here in this diagram, if you think of a displacement, the displacement of vector x is up to here and the displacement of y is up to here, which is the displacement started from here and it ended up here. So the total displacement of x and y is the displacement of z, right? It started from here and it ended up here, right? So the displacement of x and y, the sum of displacement of x and y is the displacement of z. So visually, if you add these two vectors, this is what you get. So let's try to add another vector. Okay, so let's say I have a vector, let's try with another vector. Let's say I have a vector p, okay, then I have a vector q. Okay, so vector p is heading to this direction and vector q is heading to this direction. So what is the displacement of these two vectors? That means what is the sum of these two vectors if I add? So you can easily understand that it started from here, the displacement started from here and it ended up there. So the total displacement of these two will be vector r, right? The displacement of r is equals to the displacement of p and q. So this is how you add. So let's try with another diagram. Let's try with a different one. Okay, so let's say I have a vector p which is heading to this direction and I have a vector q which is heading to this direction. So what is the sum of these two vectors? Now this is a bit complicated, right? It is not complicated at all. So as I said, you can move the vectors around, doesn't matter where you draw it, as long as the length and the directions are right, you can draw them anywhere. Okay, so what we can do is that to find the sum of these two, or find the total displacement of these two vectors, I draw p over here again and I move the q and I move the q, I put the tail of the q on the head of the p. Okay, so I draw it here, so I moved, so my length is same as it was. I did not change the magnitude of the vector, so that's why, and as well as I did not change the direction of the vector, as you can see. So I can draw them anywhere, so I put it here. So now I can easily find the displacement of p and q, which is r. So the displacement of p and q, sum of displacement of p and q is the displacement of r. So I can say p plus q equals to r. So another thing I want to mention is that whenever we are drawing a vector, so if I draw a vector which is called p, what will be the negative vector of vector p? This is, if I call it positive, if I call this vector positive, what will be the negative vector of q? This is very simple. If you just simply change the direction, then you end up with a negative vector. Okay, if you simply change the direction, the p vector becomes negative, as you can see. Let's try with another vector. If this is positive, by changing the direction it becomes negative. Okay, by just changing the direction, it becomes negative, right? And there is one more thing, that is, if you have two different vectors, vector a and vector v, if their magnitudes are same, then both the vectors are equal. We can say both the vectors are equal. So you can draw it in another way as well. If I keep the q as it is, so what I can do is that I can put the tail of the p in the head of the q, right? In that way as well, you can add these two vectors. Again, you will be ending up with vector r, right? If you add vector p with vector q, or if you add vector q with vector p, you get vector r, right? The displacement will be the same. Doesn't matter how you draw it, as long as the magnitude and the direction of the vectors are right. Suppose now let's try with two horizontal vectors. Suppose you have a vector a which is heading to this direction, and you have a vector b which is also heading to this direction. How do you add them up? So what you do is that you draw vector a over here, then you put the tail of the vector b on the head of the vector a, right? So this is where you write vector b. So a plus b equal, so the total displacement of vector a and b will be c. So a plus b equals to c. If you try this with two horizontal vertical vectors, it will be the same. Suppose if you have vector a plus you have vector b. So if you want to add them, how you are going to add them? You have vector a over here, then you put the vector b on the tail of vector b on the head of the vector a. So the total displacement is vector c. So a plus b equals to c. Okay, let's try with another one. Okay, suppose I have a vector which is heading to this direction, which is vector a, then I have a vector which is heading to this direction, which is vector b. Now I have to find the displacement of these two vectors. Okay, how am I going to do this? So as I have said, you can always move the vectors as long as their magnitude and the directions are same, right? So what you can do is that you can move vector a from there to here. So the tail of vector a will be on the head of vector b. So the displacement is c. So a plus b equals to c, because this is what the displacement is. It started from here and it ended up there. So the displacement of the sum of the displacement of vector A and B, or B and A, is the displacement of C. So A plus B equals to C.